I've opened QuikMine, and I've opened this small data set that relates to some sort of gardening or farming effort. I've got harvest weight, which is my output variable. I don't know whether that's potatoes or tomatoes or what. And the input variables that I've collected over the years is I've kept track of the temperature, I've kept track of the amount of water. I've got plots in 3 different soil types, sand, loam, and clay. And some years I use pesticide and some years not. And so these are my possible input variables. So the question often is, can I build a multiple variable model using QuikMine? And the answer is absolutely. Let's just go through and check each of our variables independently so that we're doing simple regression and one-way ANOVA, and test each variable to see if it shows some activity. And yes, temperature does make a difference, and it accounts for a fair amount of the variation. So let's check water. Okay. Whoops, that's not a Y. I clicked the wrong one. There we go. Get rid of that. Okay. An X. And click Calculate again. And this variable does make a difference, but it doesn't account for quite as much of the variation as temperature did. So let's check, whoops, come on, let's not make that mistake again. Let's check soil type. That's categorical. I've got 3 categories of soil. I'll click Calculate. And yes, soil does make a difference, and it does account for a fair amount of variation. And we pass our assumption tests. So let's then check pesticide. That's a categorical. It's a yes, no, we did it or we didn't. And the blue pointer is in the green. Makes no difference whether I use pesticide. And if that's in the green, nothing else matters very much. So now let's take all of the variables that we have used in the past and see how they work together. And the answer is they work very well together. They definitely make a difference, and they account for practically all the variation. And both of our assumption sliders are in the green. There is one other thing that we should check, and that's up here in the ANOVA table, and that's the variance inflation factor. VIF is a test to see if one variable, input variable, is really one of the other input variables in disguise. And if that's the case, they're like jealous girlfriends. They don't play well together. If your variance inflation factors are up above about 1.5, you're starting to feel a little stress, and if they're as high as 2, then usually you've got a problem and you need to go back and eliminate one of the variables. I would also recommend that you not try to do interactions, at least not try to put a whole lot of weight on them. And I would use squared terms in this context only if I had a single variable regression model where I had a Y output and an X input. Other than that, you can go through and build models this way. Once you've got one like this, if you've got a lot of variables, you may be able to fine-tune it a little bit. But that's the basic procedure for doing multiple variables.